Okay, hi everybody. So this is a video going over section 5.8 day 2. Just a quick reminder, make sure that you're watching all of the videos, okay? I've had a lot of people ask me questions, email me and ask me questions about certain things that I've explained through the video, or maybe at the end of the video, or maybe in the middle of the video. And it's getting a little frustrating. So make sure that you're watching all of the videos, okay? All the videos, beginning to end. Make sure you're listening to everything that I have to say. Okay, it's going to be extremely important while I'm out that you watch these videos. Okay, so let's start by doing this warm up. Go ahead and pause the video, just like we do each day. Pause the video and go through these warm up problems. Numbers 2 and 3 here. You're going to identify which sets of lines are parallel to one another. Okay. And then number 4 here, show that. Remember, we talked about what that means in terms of the work that needs to be shown. Show that that's a trapezoid. Okay, so go ahead and pause and then play when you're ready. All right, so I'm going to call this equation 1, equation 2, equation 3, and equation 4. So this first one here, I know that this line and this line are both horizontal lines, right? So I know that equation 1 is parallel to equation 4. Remember, a y equals is a horizontal line, so that we know this is y equals 6, a horizontal line at 6, and then a horizontal line at -8. So those two lines are indeed parallel to one another. And then we can assume that, well, the slope is 6 here. The slope is 6 here. So therefore, I know that 2 is indeed parallel to 3. And we know that also because the y-intercepts are different. All right, same thing here for number 3. I'm going to call this equation 1, equation 2, equation 3, and equation 4. All right, so this is, the slope here is 3/4. The slope here is -2. Now, I'm going to distribute in here. This is going to be y minus 3 is equal to 3/4 x. And I'm going to bring up the calculator here. 5 times 0.75, 3.75 minus 3.75. And then when I add over the 3, y is equal to 3/4 x plus 0.75. I'm going to do the same. So that means my slope here is 3/4. That's, wow, I'm really butchering that. I'm just going to move that down a little bit. Again, the slope here is 3/4. And then I'm going to do the same thing over here. I'm going to distribute the -2. So y minus 4 is equal to -2x minus 4. And then I add the 4 over to the other side. So y is equal to -2x plus 0. Well, I'm not going to write that plus 0. Okay, so we would say here that equation 1, excuse me, my phone dinging. Hold on a second. I got a text. Mrs. Napolt's back. Yes. Okay. Okay, so that means equation 1 is parallel to equation 3. Okay. Now, is equation 2 parallel to equation 4? Well, look, the y-intercept is 0 here. The y-intercept is 0 here. No, they are not parallel because they're the same line. They look parallel. It's a little deceiving, but they're not actually because they end up being the same line. Well, this is y equals -2x. This is y equals -2x. They're not parallel. It's the same line. And the last one here, number 4, show that ABCD is a trapezoid. Now, remember, for a trapezoid, we have to have one set of parallel sides. So which set do they look like? Well, I want to show the slopes for AD and BC. Okay, the slope for AD, I would go down 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4. So down 6, right 4. So -3/2. Finding the slope for BC, down 1, 2, 3, right 1, 2. -3/2. So therefore, since the slopes are the same, we know that AD is indeed parallel to BC, which means that ABCD is a parallelogram. Oh, not parallel, excuse me, trapezoid. Trapezoid. All right, cool. Okay, so why don't we get out our homework? If you haven't already done so, please submit it. Okay, I'm just going to talk through some answers here. Just talking through 9 through 12, 22 to 32 even, and then number 46. Number 9, we have equation 1 is parallel to equation 4, and we know that equation 2 is parallel to equation 3. Number 10, we have that equation 1 is parallel to equation 2, and equation 3 is indeed parallel to equation 4. And number 11 here, equation 1 is indeed parallel to equation 4, and equation 2 is indeed parallel to equation 3. Okay, so check your answers there. Number 12, show that it's a parallelogram. And again, for a parallelogram, I need to show that opposite sides, LM and PN, have the same slope, as well as LP and NM have the same slope. Okay, so that LM, I rise 1, 2, 3, 4, run 1, 2, 3. 4 over 3. Let's check PN. 1, 2, 3, 4, 1, 2, 3. Rise 4, run 3. Let's check LP. Rise 1, 2, 3, 4, left 1, 2, 3. So negative 4/3. And then same thing for NM. Rise 1, 2, 3, 4, left 1, 2, 3. Negative 4/3. Okay, so that means that LM is indeed parallel to PN, and LP is indeed parallel to NM. So therefore, and B, what the heck am I saying? And M. So therefore, that LMNP is a parallelogram. Okay. All right, let's continue on here. Write an equation in slope-intercept form for the line that is parallel to the given line and passes through the given point. Okay, so I want the line to have a slope of 3. So it's y is equal to 3x. And look here, they gave us our y-intercept. Spoiler alert, they did it down here too. Plus 4. Number 24. The slope here, if I divide over the 4, y is equal to 1/4 x. Okay, so that means that I need the slope is 1/4. And I want it to go through 0.4 comma 0. So y is equal to m times 4 plus b. 1/4 of 4 is 1. So 0 is equal to 1 plus b. And I subtract it over negative 1 is equal to b. Right? So therefore, my equation is y is equal to 1/4 x minus 1. Okay. Looking at 26 here, I got to kind of show the work for 26 down here because it needs a little bit more room. So 5x minus 2y equals 10 is my old line. I subtract over the 5x. I divide by 2, negative 2. I get positive 5 over positive 2x minus 5. I really don't care about this minus 5. The only piece I care about is the 5 over 2. And I know I want it to run through 0.3 comma negative 5. Okay, so I say y equals, let me just double check that. Subtract the 5, divide by 2. Yep. Y equals m 5 over 2 times x plus b. All right, so negative 5 is equal to, let me multiply this in my head here, 15 over 2. That's 7.5 plus b, so negative 12.5 is my b value. So my equation is y is equal to 5 over 2x minus 12.5. Okay. Let's take a look here at number 28. Number 28 here. Now, look, this is a special case. Since it's a y equals, it's a horizontal line. And what's parallel to another horizontal line? Another horizontal line. So it's going to be y equals 4. I don't really care about this 2. Okay, and I don't care about it because I only want the y value if it's a horizontal line. Let's take a look at number 30 over here. I've got to solve this for y to figure out what the slope is. So the slope is going to be 2x plus 3y is equal to 7. I subtract over the 2x. I divide by 3. Negative 2/3 is the slope. I really don't care about this 7/3. Okay, so y equals mx plus b. Again, that goes away. I only want the slope of the negative 2/3 here and bring it down. So 5 is equal to, okay, let me do a decimal here. 2/3 times 4, 2.7, we'll say. Negative 2.7 plus b. And I add that over 7.7 is equal to my b. So my equation is y is equal to negative 2/3 x plus 7.7. That's my answer. Okay. And then my last one here, number 32. The old slope is 1/2, so the new slope is 1/2. Again, don't work smart, don't work harder. The y-intercept is negative 4. So y is equal to 1/2 x minus 4. That's my answer. All right, almost done here. Last one I got to do is number 46. Jump back down there. Write an equation of a line describing a line that is parallel to the y-axis and that is 6 units to the right. I think the best way to do this one is to try to visualize it. Okay, it's parallel to the y-axis. Remember, the y-axis is this one. So if it's parallel to the y-axis, that means it's going to be another vertical line. So it's 6 units to the right of it. 1, 2, 3, 4, 5, 6. So that means this line right there, that's going to be parallel to the y-axis. That's 6 units to the right. If it's a vertical line, remember it's an x equals equation. X equals what? 6. That's my answer. Okay. Again, you're going to find that sometimes it's easier to visualize the problem, maybe graph it out and see what's going on. You guys might like that better. Okay. All right. Let's take a look here. Okay, section 5.8. If you have not already done so, please get the guided notes from the sub. This is section 5.8, day 2. Okay, day 2. So in section 5.8, day 1, we talked about parallel lines. Section 5.8, day 2, we're going to talk about perpendicular lines. Now, perpendicular lines are ones that form a 90-degree angle, right? Is anybody cold in the room? Go in the corner. It's 90 degrees. Aha, I'm so funny. See, when I'm on a video, I'm telling jokes. So perpendicular lines are ones that form a right angle. Now, what does that mean in terms of their slopes? Well, the book writes it like this. 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. That seems really weird. That seems like a really weird thing to write. I'm going to call it, they are opposite reciprocals. Opposite reciprocals are ones that are flipped, and one is positive as one is negative. Like, for example, here, -2/3 and +3/2. Those are opposite reciprocals. One is 2/3, the other one is 3/2, and this one's negative and this one's positive. If they multiplied them together, then you would be able to get -1. Okay, if you multiply together, you would get -1. But it's hard to remember to do that, and it's hard to remember to figure that out. So I just say, like, okay, if my slope is 1/3, the perpendicular slope would be -3/1. If my slope is 4, then my perpendicular slope is -1/4. If my slope is -3/2, my perpendicular slope is +2/3. And also, any two vertical or horizontal lines are perpendicular to one another. Just a few more examples down here. Oh, I did this one already. Did I do 1/5 and 5 too? No, I did 4 and 1/4. But these are just some more opposite reciprocal slopes there. Okay, so what does that mean in terms of the lines? Well, you're going to be looking at the same types of problems here where I have to look at, okay, what are the slopes for each one, and figuring out, are those indeed opposite reciprocals? Well, take a look at this first one. Isn't this a horizontal line? And take a look at this second one. Isn't that a vertical line? Okay, if one's horizontal and one's vertical, we know that they're perpendicular to one another. Here's the notation that we can use. Line 1 is perpendicular to line 2. That's how we can write that. Okay, that line, that symbol means is perpendicular to. Okay. Let's check equation 3 and equation 4. Well, my slope here is positive 3. My slope here is negative 1/3. Yes, those are indeed perpendicular. Those are indeed opposite reciprocals. So therefore, line 3 is perpendicular to line 4. This one's positive, this one's negative. This is 3, this is 1/3. You know, we can consider this 3/1, right? So that's why if we flip them, we can see that. Okay. All right, so why don't you pause and try this one? See if you can figure out which lines are perpendicular to one another. Again, this is how we're going to split it. This is line 1, this is line 2, and line 3, and line 4. Okay, so this is equation 1, this is equation 2, oops. This is equation 3, and this is equation 4. Okay, so this is a horizontal line. Do I see any vertical lines? Bingo. That's a vertical line. I know this one is a horizontal because it's a y equals. This is a vertical because it's an x equals. So I know line 1 is perpendicular to line 3. Okay. The slope here, look, is 5. This is in point slope form. The slope here, negative 1/5. Okay. Is 5 and negative 1/5 opposite reciprocals? Yep. Lines 2 and 4 are perpendicular to one another. Okay, so let's do the same thing that we did the other day with parallel lines, and let's prove something about a perpendicular line. Well, one of the only shapes that has a perpendicular piece in it is one that is a right triangle. Okay, so let's show that this is a right triangle. Remember, when I say the words show that, okay, the work is really the answer. Okay, you have to prove that this is a right triangle. And to prove that it's a right triangle, I need to show that these lines are indeed perpendicular. Now, do we see the perpendicular in there? Okay, do we see where we should create a perpendicular line? We should show the slope for AB and the slope for AC to see if they are indeed perpendicular. Okay, so let's find the slopes for each one of these. The slope for AB is rise 1, 2, run 1, 2, 3. And that's a positive sloping line. Rise 2, run 3. This one is rise 1, 2, 3, left 1, 2. Negative 3/2. Are those perpendicular? Are they opposite reciprocals? Yes. AB is indeed perpendicular to AC. Okay. All right, now, write an equation in slope-intercept form for the line that passes through 2, negative 1 and is perpendicular to the line described by y is equal to 2x minus 5. So this one is a little bit more difficult than the parallel lines just because we have to work with it just a little bit more in terms of what the slope is. See, the old line is y equals 2x minus 5. You know, if I were to graph this, y-intercept of negative 5, slope of 2, something looking generally like that, right? I want to find a perpendicular line that goes through point 2, negative 1. Okay, something that looks generally like that. It's got to be perpendicular to it, right? So we have to find the equation of that line. Now, to do so, we know what the slope should be. The old slope is positive 2. So what's my new slope? Well, my new slope, therefore, would be not positive, but negative, and not 2/1, but 1/2. And now this becomes a problem that we've done like a million times. I've got the slope, and I've got the point, and I've got to create my line. So you notice here that the only new piece that we're adding today is taking this old slope and turning it into its opposite reciprocal. Okay, so let's plug it in. Y equals mx plus b. Negative 1 is equal to negative 1 plus b. And then we add the 1 over to the other side. 0 is equal to b. Okay, so y is equal to negative 1/2 x plus 0, or just negative 1/2 x. Now, do you see here? I kind of graphed that pretty good. Look, the y-intercept is 0 right there. I kind of graphed that pretty okay. Feel good about that. Okay, so pause and try this one on your own. Remember that you're going to have to solve this for y to figure out what the slope is, and then take the opposite reciprocal slope of that. Okay, so I'm going to solve this one for y. First thing, I've got to subtract the 3. Negative 4y is equal to 5x minus 3. I divide by negative 4. And I get y is equal to negative 5/4 x plus 3/4. But I don't really even care about this plus 3/4. Right? Now, the old slope is negative 5/4. That means my new slope is going to be positive 4/5. Now, I got to run it through negative 5 comma 3. So it's y is equal to m x plus b. So 3 is equal to negative 4 plus b. So 7 is b. So y is equal to positive 4/5 x plus 7. There we have it. Good. Okay, so hopefully we all understood what was going on, and I'll see you soon, hopefully.